Okay, today is September the 4th, 2016, and we're looking at the Hawaii map, water vapor loop. We can see the remnants of Hurricane Lester, which is now a tropical storm, moving to the northwest away from the islands. And this storm is still being targeted with microwave. We can see a blast pattern right here on the south side of that storm. Let's take a look at this in the IR loop right now, the water vapor map. We can see a lot of sort of violent activity right here on the periphery of the storm, and that's where uh, we have a lot of outflow from these microwave transmitters. I'll show the next shot here. This is the visible light map, and we can see a pretty good blast pattern. We can see a lot of photoshopping until the night to day transition happens, and then we have a couple of blasts, some very good detail here. We have a blast here and one here, and we can see those craters where that roll cloud is generated, and this will move out at a very high velocity, and that's why we see these blast patterns and this shock waves moving out. Here's a couple of earlier patterns right here. We've got a roll cloud here and one here. Let's just step to the next frame. We can see that these have expanded. We go back and forth here. We can see that. And so when they superheat the core, that disrupts the convection process, and it disrupts the storm, it weakens it, and this is how they destroy these hurricanes. And depending on how much power they apply to the storm, they can wipe it out in any time frame they want. Okay, so that is the remnants of Lester. Let's go take a look at the west coast right now. This is the Northeast Pacific water vapor loop. We can see that there is a buffer zone around this storm, this tropical storm Lester, and that will prevent the jet stream from feeding this system right here. So we've got this strong high pressure. If we look at this in the IR map, we can see an area here that is completely, it's actually blockading this jet stream flow. We have a big area of low pressure here. This is an upper level low right over California. We've got some low pressure actually on the barometer today, 29.88 inches, which is as low as it's been in a long time. I haven't checked my records, but it's been, we had a similar low pressure here just a few weeks ago. And then prior to that, it was early May, I believe it was, that we had such low readings on the barometer. So going back to the water vapor map, we can see that manipulation of the jet stream right here. We have high pressure that's redirecting the jet stream up and around and down towards California. Here we have a spinning low right here, which has a transmitter on that. And we can see what's happening as this frontal system tries to move down into Southern California. Nothing's going to happen. We've had partly cloudy skies, a deep marine layer most of the day. The sun periodically will show up and then disappear. So right here we have manipulation. This is a transmitter weakening the frontal system, evaporating all that moisture that should be dropping down into California, Southern California. Now as this system moves out to the east, this will intensify. They'll pull the heat off of it, and it will quickly generate some thunderstorms and hail as it moves over the Rocky Mountains. Here we have another disturbance that has a 90% chance of hurricane formation in 2 days. So we're going to watch that one. These waters down here are in the high 80s. So we'll see high pressure continue to be maintained in this area to prevent that system from moving north. Although we do have low pressure up in this area right now in the LA area. We'll show you that on the maps, the pressure maps. Now let's take a look. This is the East Coast. We have Hermine, which is this is the forecast. It's supposed to move further north and then possibly make a right turn. Let's look at the East Coast maps first. This is the storm right here, and we can see a right angle right on the core of that system. I'm going to stop this loop, and we'll take a look at that right here. I'll put the envelope right here on the corner, and we can see how well so there is a transmitter on that system, and that is pushing it away from the mainland. You see we've got a straight edge on this side and on that side. So on both sides we've got a transmitter, phased array type transmitter, and that is generating high pressure in this area, and that will steer that storm away. That's what it's doing. And also we have high pressure in this area, very dry area. In that area, let's run the loop. And we have a lot of violent activity right here. Thunderstorms redeveloping. We can see the tremendous flow to the east-northeast right here. All this artificial high pressure from that transmitter. And all of this moisture is being redirected. We've got a couple of transmitters here. We can see the clockwise rotation on both of these. That is going to redirect all this moisture away from this system right here. And we can see that this buffer zone right through here, and that will prevent any merging of these two areas of moisture. Here on the rainbow loop, we see a very wide area of dry air. We've got all this moisture moving along, and that will not merge with this. We don't see all that important detail in this map. We have to look at the water vapor loop to see the transmitter outline, the RF working the area here and evaporating all that moisture. All right, let's look next at the, this is the west coast and western U.S. You can see that trough of low pressure. This is trying to spin up. If there was not a transmitter right here, we'd be getting rainy weather in September. So-called El Nino, which never happened this year or the last year or the year before that. So this year, I guess this coming season, I guess they're going to try a La Nina, see if that works. Doesn't matter what they call it, we're not going to get any rain with this kind of stuff going on right here. That's a transmitter right there focusing, cutting this moisture field right in half right here, just in time to go right over Southern California. And we have something down here trying to spin counterclockwise. We'll keep an eye on that. Here is the IR map. There's zero precipitation in California and on the East Coast as well. If we go back to that East Coast map, the Weather Channel was showing this entire map, and there was zero precipitation in a lot of states all the way through the Northeast. Okay. All right, we saw that. Here is the hurricane map for the West Coast, and now we have, as of about an hour ago, we've got Tropical Depression 15E, 35 mile per hour winds, core pressure of 1,005 millibar, and the storm is moving very slowly to the northwest at 2 miles per hour. We'll keep an eye on that. We saw those. Here's the pressure maps. You can see big high pressure out here on the East Pacific. We have an area of low pressure where that surface low right there. We have Lester out here. Here's the 500 millibar. We see a low pressure area right here moving through. It has a transmitter on it. High pressure out here. Here's the 300 millibar. And we see some strange stuff going on here. There is a transmitter heating the core of that system. And this odd squiggly line here will help explain part of that. Got some strange things happening there. Okay, here's the SSEC map, the water vapor map, showing the Pacific and the West Coast. Got Leicester right there. And we have the West Coast. You can see that spinning low right here, which looks like it has a right angle on it. Look at that, right there. Right angle cut out on that center of that. Also, we have what looks like some clockwise rotation trying to develop right here. Clockwise rotation in the middle of that storm system. That's about as good as it gets as far as proving weather manipulation. Now I can stop this video right here and zoom in. Let's take a look at that. There's the right angle right here. It's about as good as it gets. Let's put the envelope in there. Okay, I think I made the point. Okay, so that is the report, and we'll just leave it here. We can watch this right angle right here. The system right there. Okay, that's it.